All right, so today, y'all gonna be able to determine if the sum or product of rational and irrational numbers will be rational or irrational. So usually I don't show you the APKs in the videos, but this one's actually really, really good. So two good oranges will make all good oranges. All right, well, a good orange to me is gonna be our rational. All right, now I'm gonna say that that's good because rational is a bunch of different numbers all playing well together, right? We have natural, whole, integers, rational numbers. They're all rational. All right, so when I have two rational numbers, whether I add or multiply, I'm always going to get a good orange or a rational number. On the other side of things, if I have a bad orange, or I'm going to call it irrational, all right, and I'm saying that the irrational numbers are bad because they don't like to play nice with the other ones. Remember, they're on their whole other island. They're out there in Canada. However, whatever you use to remember it, they're their own thing. They do not like to play nice with others. So when you combine one bad orange or one irrational orange with a good orange or rational orange, we're always going to get an irrational orange or number, sorry, right? And that's whether we're adding or multiplying. All right, so this is really just the two things that you need to remember today. All right, so I'm going to go through a couple of these. It would be super helpful for you if you either had this diagram out that I put in your Schoology accounts, or this one's even better, and it gives you examples: rational numbers, member, natural, whole, integers. All of these four are rational numbers. Over here by ourselves are irrational. So if you have any questions on what a rational or irrational number is, I suggest you watch the previous video. All right, so the product of two rational numbers, right? We have a rational number here, 3.14 times, which is going to be our product, -7, is always going to be rational. All right, just like I said before, the sum or addition, the sum of two rational numbers is always going to be rational. All right, here you might look at this. This is an integer, no problem. 25 is a natural number, sorry, a counting number, no problem. Some of you guys might look at 3.14 and be like, it's pi, but it's not. Remember, the only decimal that is irrational has a ... at the end. ... So as long as it doesn't have that dot, I don't care how long this decimal is, as long as it doesn't have that ... this is a rational number. All right, same thing here, 5.16. We know that we have this bar over top of it. And when we have that bar, it means it's repeating, which means that it's rational. Okay. All right, on the other side, we also have product. So the product of a non-zero rational number and one irrational number is always going to be irrational. So when I look at these two numbers, I know that I'm doing my product here. This is a decimal that does not have the ... so it's terminating. So this is my rational number. Right, and then when I take this square root of 30, you plug it into Desmos. I'll go ahead and show you that real quick. I plug in square root of 30. We get a decimal, all right? You don't even have to really look at this number to think about this, right? Just know that if you take the square root of a number and you do not get a whole number, right? You do not get a natural number. Right away, it's not a perfect square. Therefore, it is always going to be irrational. All right, this works for the sum as well, right? For addition, one rational number and one irrational number is always going to be irrational. Well, I know that this is a mixed fraction. So 2 2/5, it's a fraction. right? So this is definitely rational. And if you take the square root of 15, you are not going to get a perfect square. So this will be your irrational. All right, I'm going to go through these pretty quick. Calculate the sum, tell whether it's rational or irrational. So this guy right here is going to be rational. -1 is an integer. Pi, we know pi as a symbol is always going to be irrational. So if one of these two numbers is irrational, our answer is irrational. All right, again, I have a half, which is a fraction. So I know that that's going to be rational. And then I have 6.34. And here are these dots I've been talking about, right? This is our cray number. Cray, do. Sorry. So this is definitely going to be an irrational number, which, even though we're multiplying, will be irrational. All right, here I've got a decimal that terminates. So this is rational. And I have a fraction, which is also rational. So my answer is rational. I have the number 9, which is rational. This is a natural number, a counting number, which is in the subset for rational numbers. I have 2.3 with the line over the top. When I have that line over the top, means that this is repeating, which means that it is also rational. So my answer again, rational. All right, now here's a good one for you. We know that 3 is rational, right? Because it's a whole number. Well, and a natural number, right? It's a counting number. And we know that 22 over 7 is rational because it's a fraction, right? And that's the definition of rational numbers. But I saw a lot of people doing this. And what we do is they want to come into Desmos and be like, oh, let me try this. 1, 2 divided by 7. And they get this big, ugly looking decimal. All right. And this causes a lot of confusion. Because then you want to say, oh, it's irrational because none of these numbers make sense. There's no pattern. It's just an ugly decimal. You can't do that. All right. You don't know when that number is going to stop. All right. Desmos is not going to give you that ... you need for irrational decimals. So you need to know that 3 is rational and this fraction is rational, which will give you your answer as rational. All right. And the last one, we know 6, again, natural number, rational. Square root of 11 is not a perfect square. Irrational has to be irrational. Remember, 2 good oranges, going to stay rational. 2 rational is going to stay rational. If you throw 1 bad orange, 1 irrational in there, your answer is always irrational. All right, have a great weekend. I'll see you all on Monday.